Hi, everyone. Today in this webinar, I'll be talking about from legacy to cloud native. I am Michael Tilman. I'm the North American Solution Architecture Manager. I've been around for around 15 years doing various jobs within the tech industry. And yeah, the very first part of this, and I'm going to go over quite a few things today and talk about a lot of the pros and cons of cloud native versus legacy. But realistically, this first part, what I want to talk about is why cloud native. So why would you modernize your virtualization? And quite frankly, the business drivers are very clear, and legacy platforms are expensive, they're slow, and they're not designed at all for the agility financial institutions now require. However, cloud native offers a way forward. So as digital transformation accelerates across the financial services industry, the pressure on IT departments to modernize their legacy infrastructure has never been greater. The traditional virtualization platforms that used to be the bedrock of data center architecture now pose a significant challenge, and that is with escalating costs, operational bottlenecks, and increasingly rigid vendor ecosystems. Financial institutions are under intense scrutiny to comply with these ever-evolving regulatory requirements to ensure data sovereignty and deliver new digital services with speed and reliability. Legacy infrastructure often becomes the bottleneck, limiting agility and inflating your operational risks. At the same time, newer technologies like containers and Kubernetes are proving to be a very natural fit for secure, flexible, and high-performing digital platforms. I will explore how these cloud-native virtualizations powered by Kubernetes and Mirantis Cloud address these challenges head-on. I will delve into real-world use cases from one of the leading financial institutions, demonstrate the technical and business advantages of adopting a Kubernetes-native virtualization platform, and share lessons and best practices for IT teams on the path to modernization. So what are the common challenges with your legacy virtualization? And one of the things that we've heard from our customers worldwide is one of our banks saw a 60% increase in licensing fees after a pricing model change, and another one failed a compliance audit due to inconsistent patching. Financial institutions often operate complex, mission-critical systems that were virtualized over a decade ago using platforms such as VMware vSphere or Microsoft Hyper-V. These platforms have since become increasingly costly and an operational burden. What are leading to these licensing costs? There's a couple of things that lead to this. The licensing structures have become more complex and expensive, often based on your per core pricing. Another item that leads to your licensing costs is long-term enterprise agreements, and they reduce flexibility and increase your TCO, or total cost of ownership. So for example, one of our mid-sized regional banks reported a 160% increase in their annual virtualization software spend after their major vendor shifted from socket-based to core-based licensing. This unexpected hike forced the bank to delay other strategic IT investments. Such cost increases also limit their innovation as IT budgets become consumed by infrastructure maintenance instead of modernization. Another thing that lends to this is your vendor lock-in. So proprietary APIs, management tools, and integrations make switching very costly and technically difficult. Limited supply for open standards hampers your innovation and hybrid cloud strategies. So one of the multinational financial services that we provide service to attempted to integrate a cloud provider storage service with their legacy virtualized environment, but they faced significant compatibility issues due to proprietary interfaces, resulting in a costly 6-month delay in their hybrid cloud rollout. Vendor lockout can also impede your compliance initiatives if critical updates or support are delayed due to dependencies on a single supplier. One other thing is operational complexity. So VM provisioning can take days or weeks due to ticket-based workflows. Automation is often bolted to post facto or creating fragile pipelines and tool chains. So an example of that is a global insurance firm shared that provisioning a new VM could take up to 2 weeks due to their internal handoffs, change control approvals, and manual configuration steps. This inefficiency hindered their development velocity and slowed time to market for new digital services. Fragmented toolset, that often means different teams like DevOps, SecOps, etc., operate in silos, increasing your miscommunication and errors. And the biggest thing actually is security and compliance risks. Patch management is slow and manual, increasing the window of vulnerability. Compliance audits are resource intensive due to poor observability and lack of declarative configuration. In one case, a financial institution discovered during a regulatory audit that dozens of their VMs had not received their critical patches for over 90 days. An incident led to a formal warning from their regulator and required an urgent remediation campaign that consumed substantial engineering resources. Legacy environments often lack role-based access control, or RBAC, and real-time monitoring, making it harder to enforce zero trust principles. And those are some very real things that financial institutions are faced with in a day in, day out scenario. So why Mirantis? To overcome these limitations, forward-thinking financial organizations are adopting cloud-native virtualization. Mirantis Cordant provides a Kubernetes-native virtualization platform that aligns with principles of cloud-native architecture, enabling institutions to run VMs and containers side by side with a unified control plane. So let me talk for just a second, and I'll dig down into the pieces in just a second. But inevitably, what I want to talk about is Cordant and what it does and what it is going to do. So if you look at the top, Cordant is a multi-cluster hybrid multi-cloud. Cordant is at the top. It's our flagship product at this time. The multi-cloud infrastructure lifecycle management, application cataloging, and cluster store management, open observability, platform, and cost management. I'll go deeper into these in just a second. But if you look on the left-hand side in the virtualize portion, we have two different capabilities here. That is the Mirantis OpenStack and the Mirantis Kubernetes Virtualization, or KubeVirt. Some of those use cases are 5G and edge, infrastructure as code, your legacy workloads, and data sciences. Now, if you look down into the center, the operate and observe, and I'll be talking more about these in detail in just a second. Stacklight, which is our LMA stack, Lens, and then from the security standpoint, the Mirantis Secure Registry is our image store, and the Mirantis Container Runtime is the container runtime. So now, more importantly, if you look on the right-hand side under the containerize, you'll see the Mirantis Kubernetes Engine, NK0s, and some of those use cases specifically are Kubernetes, IoT, 5G and edge, regulated, and hybrid cloud. And I'll be going deeper into these as we continue down the road. So let me dig down just a little bit about what Mirantis Cordant is and the value proposition of what Cordant provides. Cordant is our solution for modern virtualization. It leverages proven CNCF projects to offer a cloud-native path forward without abandoning your VM-based applications. Cordant is a Kubernetes-based platform designed to manage distributed infrastructure at massive scale. It offers a declarative approach to cluster management, providing a modular an extensible architecture that enables organizations to efficiently deploy and oversee Kubernetes clusters across various environments. So some of the key features of Cordon include scalability, and it is designed to handle large-scale infrastructure deployments. And Cordon leverages Kubernetes stability and maturity to ensure reliable operations. Flexibility. Cordon supports deployment on any CNCF certified Kubernetes platform, offering organizations the freedom to choose their preferred hosting environment. And observability and FinOps. The platform includes Cordon Observability and FinOps, or COF, and that provides enterprise-grade monitoring and financial operation capabilities for managing your Kubernetes clusters. By integrating Cordon into your operations, organizations can achieve streamlined infrastructure management, enhanced scalability, and improved observability, leading to more efficient and cost-effective IT operations. So I'm going to talk just a little bit in a second about some of the things that are viewed on screen here, such as KubeVirt, MetalLB, Prometheus, and Grafana, and of course, the Mirantis enterprise support. What are the key components of Cordon? And Cordon is an open source platform designed to facilitate the deployment and management of Kubernetes clusters at scale. Its architecture components comprised of several key components, each serving very distinct functions. So the Cordon Cluster Manager, or KCM. KCM is responsible for the deployment and lifecycle management of Kubernetes clusters. It leverages the Kubernetes Cluster API, or CAPI, to treat clusters as Kubernetes objects, enabling operations such as creation, configuration, updates, and deletion through declarative definitions. Within a Cordon management cluster, a cluster deployment object represents a deployed cluster, encompassing the machine objects and other related resources. When a cluster deployment is created, KCM provisions the cluster. When deleted, it deprovisions it accordingly. Cordon State Manager, or KCM. KCM handles the installation and lifecycle management of services, policies, and Kubernetes API configurations within these clusters. It integrates with open source projects, such as Helm and Sveltos, to manage services and applications as Kubernetes objects. This integration allows for the deployment and management of beachhead services, policies, and configurations, ensuring that the clusters maintain the desired state as defined by you, the user. Cordon Observability and FinOps, or COF. COF provides enterprise-grade observability and financial operation capabilities for Cordon-managed Kubernetes clusters. It offers centralized metrics collection, logging, and cost management through the open telemetry-based architecture. COF enables real-time and historical analysis of metrics using a time series database, aggregates and analysis of those logs for troubleshooting, and it evaluates alert rules to notify users of potential risks and potential issues. On the financial side, COF assists with cost tracking and management by providing insights into resource utilization, facilitating chargeback, showback mechanisms to attribute costs to specific teams or projects, therefore promoting accountability and transparency in resource utilization. Together, these components form a comprehensive system that supports platform engineering teams in managing Kubernetes clusters and services across diverse environments, ensuring consistency, compliance, and operational efficiency. So now let me just talk real quickly about the Cordon architecture and what that means. So as I just discussed, KCM, KSM, and COF are the three main components of Cordant within the management cluster. So what does that mean in this specific diagram? On the right-hand side would be a deployed regional cluster. And what does that mean? So KCM is going to have within and control the managed Cordant cluster with enterprise workloads, a base and custom services is going to be managed by KSM, and KOF is going to have within that managed Cordant cluster the regional high performant for tracking logs, metrics, traces, and statistical data within that region. So basically, the management cluster is dealing directly with the regional clusters that have been deployed by KOF. So now I'm going to talk about a couple of the key additional components. KubeVirt. And what does KubeVirt do? KubeVirt lets you run your legacy applications within Kubernetes. This helps bridge the gap between traditional and cloud-native infrastructure. It allows Kubernetes to manage and run traditional virtual machines alongside containers. It provides virtualization capabilities within Kubernetes clusters, enabling organizations to keep legacy workloads while adopting modern cloud-native patterns. Financial services can use KubeVirt to lift and shift legacy applications into a Kubernetes environment without re-architecting them, especially valuable for critical workloads that cannot yet be containerized due to compliance or software dependencies. So let me talk just a second about the specifics of KubeVirt. The virtual machine and virtual machine instances, or VMI. The virtual machine is a declarative configuration via a YAML file that defines the desired state of a virtual machine, similar to the deployment in Kubernetes. The virtual machine instance is a live running virtual machine derived from that configuration. You can create, stop, and restart VMIs the same way you manage pods. The KubeVirt operator simplifies the installation and lifecycle management of KubeVirt in your cluster. It installs the CRDs, or the custom resource definitions. It also installs the controllers and all of the required Kubernetes components. It also has live migration support. KubeVirt supports live migration of running VMs across nodes. It uses shared storage, such as Ceph or NFS, and memory copy over techniques. This is very useful for maintenance windows or load balancing without downtime. Storage and volumes. The VMs can use Kubernetes persistent volume claims, or PVCs, for disk storage. It also supports container disks, which are ephemeral OS image for testing and dev environments. PVCs, as I just mentioned, for persistent root and data disks, and data volumes via the CDI, or the containerized data importer. This basically automates importing disk images such as QCOW or ISO into those persistent volume claims. Some of the networking options. KubeVirt integrates directly with the Kubernetes Multos for advanced networking scenarios. And basically, you can attach multiple networking interface, such as PCI DSS for network segmentation. And it also uses SROV, MAC VLAN, and Bridge CNI plugins. The default for pod networking, Virt Launcher Pod, can also be extended. Now, the security features that KubeVirt supports is SE Linux, AppArmor, and SecComp for workload isolation. You can run VMs as non-root. You can use Kubernetes RBAC and namespaces for access control, and encryption in transit and at rest through integration with Kubernetes features and storage backends. Monitoring and observability is it exposes Prometheus metrics like VM lifecycle, running, paused, stopped, for example, and resource consumption, such as CPU, memory, and disk I/O. And it integrates easily with Grafana dashboards and I'll be talking about that more in depth here in just a second, and can be linked with alerting pipelines for uptime SLA enforcement. So some of the features that are a financial benefit is the unified management. It's basically one platform for VMs and containers, less tooling and less training. It is GitOps ready. It's declarative VM configuration, audit trail, and easier compliance. Live migration enables zero-down infrastructure maintenance, namespace isolation, and RBAC. This basically enables secure multi-tenancy for business units or environments, Multis and SROV networking. It aligns with regulated data zone architecture requirements, and hybrid cloud ready. VMs and containers portable across on-prem, edge, and cloud. So now let me talk just a little bit about MetalLB and load balancing and why it's important to financial institutions. MetalLB ensures reliability across all of your networks for workloads running either on-prem or in hybrid environments. And this is crucial for high availability, especially within financial applications. MetalLB is a load balancer implementation for bare metal Kubernetes clusters. It allows external services to be exposed via standard IP addresses without relying on your cloud provider specific load balancers. For financial institutions hosting Kubernetes on-prem for compliance reasons, MetalLB ensures production-grade network availability and redundancy. A trading platform operator using MetalLB with Cordant to expose internal applications securely and reliability across two geographically redundant data centers is a very good example of why you would need and want to use MetalLB. So down into the specifics about what MetalLB really is. It provides external IP addresses managed over layer 2 and BGP-based load balancing. It enables Kubernetes services of type load balancer in environments that don't have cloud-native load balancers, such as AWS ELB or GCP L4 and L7. So why do you need MetalLB? Kubernetes assumes that some kind of load balancer is available when you use the service type load balancer. On-premise clusters or clusters in an air-gapped financial environment don't have one by default. So MetalLB fills that gap by assigning real routable IP addresses to Kubernetes services. It handles all of your inbound traffic routing to the right pods via L2 or BGP protocols. And it supports redundancy and high availability for critical financial applications. So how does MetalLB do this? It supports the two main operational modes, Layer 2 and BGP. So the Layer 2 mode uses ARP or NDP to advertise your service IPs on the local network. It's a very simple setup, ideal for flat Layer 2 networks, which is typical along most enterprise data centers. The only drawback is it does not scale well across subnets or multi-site deployments. BGP mode advertises your service IPs via Border Gateway Protocol, or BGP, to upstream routers. This is suitable for complex or multi-site enterprise networks, and it enables more advanced routing policies and resilience. MetalLB responds to ARP requests for the service IP and forwards your traffic to the correct backend pod. So let me talk just quickly about what the use cases for financial institutions are. Exposing internal banking services or APIs with high availability using load balancer IPs. Providing a non-NAT access to services for monitoring secure tooling or compliance scans. Enabling east-west traffic between sites in an active-active setup using BGP mode, and redundant failover routing with multiple routes for DR scenarios. So integration directly with Cordant and Kubernetes. So Cordant workloads, VMs, and containers can be exposed via a service of type load balancer using MetalLB. This is ideal for VMs that expose services such as HTTP API or secure FTP. Load balancing across VM replicas or pods in HA setups. So what are some of the security considerations? You absolutely have to scope address pools carefully to prevent IP conflicts. Use RBAC to restrict who can modify MetalLB config maps. And in BGP mode, you've got to enable MD5 authentication for secure BGP peering with routers. Some of the pros and cons for layer 2 mode. A pro would be simple setup and works with flat networks. One of the cons is it doesn't necessarily scale across subnets. BGP mode is one of the pros is it's scalable, multi-site, and integrates with enterprise routing. One of the cons is it requires router support and configuration. Native Kubernetes API, one of the pros is seamless integration with service type load balancer. One of the cons is it needs IP address pool planning. One of the examples in practice that I'd like to talk about is one of the regional banks that's one of our customers is running Kubernetes clusters on premise, using MetalLB to expose their legacy loan processing VM via Cordant and internal analytics APIs and Prometheus and Grafana dashboards. They configured 2 load balancer pools, one for production and one for development. This setup allows their SOC team to scan all environments using routable IPs without port forwarding hacks or VPN dependencies. Very good example in practice on how you would leverage this with Cordant and MetalLB. So now let me talk about observability with Prometheus and Grafana. So observability is a key pillar of compliance, especially within financial services. And Prometheus is a time series data for collecting and querying metrics, while Grafana provides a powerful, customizable interface for visualization. Together, they form a robust observability stack used to monitor the health, performance, and behavior of infrastructure and applications. With Cordant, financial organizations gain out-of-the-box visibility into virtual machine uptime, Kubernetes resource usage, security events, and system health. One bank used these tools to establish real-time compliance dashboards that monitored policy violations and flagged security anomalies, reducing audit preparation time and improving incident response. So what is Prometheus? Prometheus is an open source monitoring and alerting system built for reliability and scanning in cloud-native environments. It collects metrics from configured targets at specific intervals. It stores data as time series identified by metrics name and labels, providing a powerful queryable language called PromQL. It also exposes data over HTTP for visualization or alert evaluation. Some of the core principles in Prometheus: as a time series database, it's optimized for storing large amounts of metrics with efficient compression. PromQL is a flexible query language for aggregating, filtering, and calculating metrics. Service discovery automatically discovers targets like pods or virtual machines using Kubernetes APIs. It is a pull model. Prometheus pulls metrics from endpoints via a push model used by others. And Alert Manager. It handles the deduplication, grouping, and routing of alerts via email, Slack, PagerDuty, etc. What is Grafana? Grafana is an open source analytics and visualization platform that integrates seamlessly with Prometheus and many other data sources. It creates dashboards to visualize time series data. It supports alerting directly from dashboards, and it enables role-based access control and folder structures. It's ideal for compliance dashboards, performance monitoring, and SLA tracking. So how does Prometheus work within Kubernetes? So an example workflow in a Kubernetes cluster is Prometheus discovers that a target is down. It finds the pod, the service, the node, and endpoints. It scrapes the metrics endpoints exposed by Kubernetes itself via the kubelet, kube scheduler, kube controller manager, application pods, and exporters. And all of these metrics are stored with labels. How does Grafana complement Prometheus? One of the use cases is real-time dashboards of virtual machine and pod health, resource usage, Kubernetes control plane status, and network activity via MetalLB or Calico metrics. Audit dashboards for compliance changes, SLA compliance, and historical trends for incident retrospectives. Some of the dashboard examples could be a Kubernetes cluster overview, such as nodes, pods, CPU and memory usage, a VM dashboard that gives number of VMs by state, either running or failed, CPU, RAM, and I/O metrics, alert history, what has fired, when, and who acknowledged it. Alerting with Prometheus and Alert Manager. Prometheus rules can be evaluated and routed to Alert Manager, which can group alerts by service or severity, silence known issues, and send notifications to either email or Slack or whatever. So basically, in summary, Prometheus is a metrics collection and alerting engine. Grafana is a dashboard and visualization front-end data handler. The data handling, Prometheus uses pool-based time series database. Grafana queries Prometheus and other sources. From a security and compliance, Prometheus is detailed time-stamped metrics, and Grafana has RBAC, folders, and immutable history, and these are ideal for VM, container health, and audit trails, and it gives you visual reports for ops and compliance. All of these components that I just spoke about are integrated and supported by Mirantis as part of our broader Kubernetes and container infrastructure platform, providing a cohesive, enterprise-ready environment that enables organizations to simplify infrastructure, improve security posture, and accelerate innovation. What are the key benefits for you as a financial institution? And these benefits translate directly into operational agility, cost savings, and reduced risk, all top concerns for CIOs and compliance officers. A unified operation. You can manage both VMs and containers with a common tool set. Teams use Kubernetes-native tools like kubectl, Helm, and Argo CD to handle all of your workloads. One real-life use case is a bank reported a 70% reduction in operational overhead and faster delivery of internal services after adopting Cordant. Cost optimization. You can avoid expensive hypervisor licenses and proprietary platform lock-in. You can run on commodity hardware without specialized vendor support. One real-world use case here is a European fintech saved over 500,000 euro in 1 year by migrating their test environments from VMware to Cordant. Another key benefit is security and isolation. Namespace isolation, RBAC, and policy controls create secure multi-tenant environments. An immutable infrastructure and Git-based change control prevent configuration drift. A real-world use case for this is a wealth management firm passed an external security audit with zero critical findings after deploying Cordant. Compliance alignment. GitOps offers a full audit trail of infrastructure and policy changes. Integration with policy as code tools ensures alignment with internal governance and external regulations like PCI DSS and SOX. A real-world use case here is one of our North American investment banks reduced audit time by 50% using their custom Grafana dashboards and version-controlled manifests. And last but not least, cloud and hardware agnostic. You can deploy on bare metal, private cloud, or extend to public clouds for hybrid or your disaster recovery scenarios. A real-world use case for us is a credit union deployed Cordant across 2 physical data centers and later extended their workloads into AWS without rewriting code. Now, one of the case studies that I'm going to talk about is a real-world example of transformation. This bank turned around its operations and compliance posture by moving to Cordant. This leading national bank with more than 20 million customers faced significant challenges, and its aging virtualization environment with mounting pressure from executive leadership to cut IT costs and accelerate digital services. The bank's infrastructure team began exploring cloud-native solutions. So what was the problem? The problem was they had over 3,000 VMs across multiple data centers being managed using legacy virtualization platforms. The annual licensing and support costs exceeded $7 million. Providing a new VM for development could take 1 to 2 weeks. And the bank failed a compliance audit due to inconsistent patching and lack of traceable change history. So what was the solution? The bank partnered with Mirantis to deploy a pilot using Cordant in its development environment. Within 90 days, they had successfully migrated over 200 VMs to a Cordant managed cluster running on bare metal. GitOps and Argo CD were implemented to manage both VM and container deployments. Prometheus and Grafana were configured for real-time observability and compliance monitoring. What was the result? It reduced VM provisioning time from 10 days to under 1 hour, saved over €2 million annually in licensing and support costs. It passed the next compliance audit with full traceability of infrastructure changes, and they enabled a hybrid environment running mission-critical applications across on-premise and cloud infrastructure using the Cordant platform. So what are the lessons learned? Some of these best practices can help you get started and avoid common pitfalls that are plaguing very many financial institutions. Cordant's integration and support simplify your journey. Start small and iterate. Begin with a pilot to prove out the model. Focus on non-critical workloads to gain confidence. Involve security and compliance early. Bring risk and compliance teams into the design phase to ensure governance and audit readiness. Prioritize observability. Implement Prometheus and Grafana from the start to track system health and compliance metrics. Adopt GitOps immediately. Use declarative configurations and version control for infrastructure changes. This improves traceability and reduces the risk of configuration drift. Train and cross-enable teams. Ensure infrastructure, DevOps, and security teams are trained in Kubernetes, GitOps, and Cordant principles to avoid operational silos. And last but definitely not the least, avoid DIY integrations. Use the integrated, tested stack provided by Cordant to reduce complexity and maintenance burden. So in conclusion, to stay competitive and compliant, financial institutions need to modernize. Mirantis Cordant offers a clear, supported, and open path forward. Traditional virtualization platforms, while founded to the IT infrastructure of many financial institutions, are becoming increasingly misaligned with the demands of modern digital banking. Their high costs, lack of agility, and limited compatibility with cloud-native paradigms hinder innovation and slow the delivery of financial services. Mirantis Cordon presents a powerful alternative, a Kubernetes-native virtualization platform that allows financial institutions to run VMs and containers side by side, automate infrastructure with GitOps, and enforce security and compliance policies and unlock hybrid cloud flexibility. With core technologies like KubeVirt, MetalLB, Prometheus, and Grafana, Cordon enables organizations to lower your infrastructure and licensing costs, improve development velocity through automation, strengthen security and compliance postures, and prepare you for a multi-cloud and hybrid future. As illustrated in that real-world case study, transitioning to Cordon can lead to measurable gains in cost efficiency, security, and operational agility. By starting with a well-defined pilot, engaging stakeholders across IT and compliance, and leveraging open standards, financial organizations can confidently modernize their virtualization strategies. Now is the time for financial institutions to move beyond legacy systems. Cloud-native virtualization with Cordon is not just a technology upgrade, it's a strategic enabler for digital transformation. So what can you do? We invite you to take the next step, explore these resources, and reach out to our team for a personalized consultation. Thank you very much. Have a great rest of your day.